Hey everybody, this is Larry. This is April 22nd, the third week of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem, The Brick Wall. So I usually stop these live, so if it's a little bit slow, watch on 2x, fast forward or whatever you need to do. So again, my mic kind of cut out, which is kind of sad. I really need to be better about, I don't know, I'm going to have to get a new mic. But now my sound quality might be a little bit worse because I'm on my on a cheaper headphone. But yeah, but for this problem right now, I'm just looking at the problem. I'm looking at the bricks. I read the problem a little bit. I mean, like out loud, but yeah, and I was commenting on, wow, the input is kind of really funky. You have to kind of visualize it in a different way. And fortunately, they do have a picture for you to kind of help visualize it. And then next, I looked at the constraints a little bit, and I was like, oh, 10,000 by 10,000 is a lot. But then it's also said that the total number of bricks is not over 20,000, so that's okay. Yeah, and then my first thought here is something along the idea of sweep line algorithm. I think that's when I, use. I mean, I'm still reading. I think at this point, and just kind of make sure I understand this problem a little bit better. And yeah, and then here I just basically still keep on looking a little bit, just thinking, because that's how, this is a live problem, a new problem for me. So yeah. So I think at this point I was like, oh, maybe you can do some sort of sweep line going from left to right, which is how I usually do sweep line. And then the thing I noticed is that, okay, on the you always want to draw a line within or on the edges of a brick, right? And you can also look at this as a as a shortest path from the top to from the bottom. But I think from thinking about it like that, it occurred to me that the cost is 1 when there's a brick and 0 when there's no bricks, and everything is integers. So you just have to figure out how many bricks does it cost, or the opposite of that problem, the inverse of that problem, which is how many endpoints of a brick are there that you're going through, so then you calculate the reverse of it. And I think the other thing that I noticed is that, well, the two things. One is, you never want to do it at the beginning, so I mean, that's just in a problem, and you don't want to do it at the end, so we can actually skip the last number. We can skip the last number because, again, you don't, it doesn't, you don't go through the end anyway. So yeah, because at the end, all the sum should be added to the same, and I think I look at the constraints in that way. Yeah. And honestly, I don't remember everything I said because I say a lot of stuff. But I think I'm talking about along those lines. Maybe making more, but I did make the observations at some point about that, an integer, and that, I think for now, because of that, you just want to see which endpoints they line up. So in effect, because these are all integer with bricks, we can just use a frequency map to kind of figure out, where the essentially prefix sum, but it's just like a rolling sum for each row. And this is what we start coding here, that for each row, we set the offset as 0, and then we go one by one to kind of calculate the offset of the gaps on each row, and then we keep track of it in a frequency map, as we say. Yeah. Might have been slicker when I was doing it, but I need a new mic. Apologies for that. But yeah, so now we set everything offset. We count the number of offsets. So then I was going to write a for loop to kind of commemorate this problem. Because basically I'm here now, I'm explaining that what I kind of already did on this part, which is that you want the opposite of it, because instead of counting the number of bricks, you want to count the number. You already counted the number of gaps, so now you have to reverse it back. And I was going to write a for loop to just get the max of the things that we've seen, but I've been trying to do a little bit more Python stuff. So I was just reducing it to one-liner, and I think I'm still explaining what I was trying to do here with respect to the inverse of the function of the problem. So now we just have to, and I also mentioned that we don't care about the x values of like the offset of those values. We just care about the what actually comes up the most frequent. So max of f values should be good enough. And here, the max of f dot values, the frequency map, is the number of gaps that we went through. So the inverse of it is just the number of rows minus the number of gaps. So I hit submit here, but there is actually a bug, which is that if there's no values, max doesn't actually return 0. Maybe it should, to be honest, but that's another story. And I was talking about here where normally I would write a for loop in other languages to get the max, and this wouldn't happen because the set to no value would be 0. But in this case, I messed up. Whoopsie daisies. So I just added an if statement to fix it. But yeah, and now I'm just double checking, reading the problem again. And I talk about how in a greedy way you actually want to always go through, the beginnings and the ends of the bricks. But technically speaking, you can actually go through the middle of a brick, but it will never be optimal. Except for in the case where there's no endpoints to go through. So this is why we have to make this minor change, because I at the time I think I was just not thinking about this being a valid input, but it turns out that it was. So I ran it, I submitted, and I also should have tested more, but I was just a little bit lazy given or optimizing for time of the video. But yeah, and then now I'm going through the complexity of the algorithm. It's going to be linear time, linear space. Even though there's number of rows times the number of columns, that is the linear in the size of the input, and you look at each brick once. And in terms of, so that's going to be linear time. In terms of space, we look at each frequency. You can construct an input such that each frequency occurred once. And so then, the frequency is going to be linear space because it's going to be row times column space and row times columns time, which is the size of the input. Yeah, and I think in this video right now, or maybe a little bit after this, I talk about how, sometimes if you get stuck on a problem asking you to do a very specific thing, try to think about the inverse of it, the opposite of the problem, and see if you could solve for that, and then figure out the relationship between the two. That's basically what I did here, and that allowed it to be that allowed it to be solved. So yeah, that's basically all I have for this problem, explained in a different way. So hit the like button, hit the subscribe button, join me on Discord. Hope y'all have a good rest of the week. Hope y'all have the good rest of the month. Take care of yourself. And to good mental health. And I will see you later. Bye-bye.